Alrighty, hello everybody. Welcome to the October edition of EdmontonPy, PyYYC, and PyData Calgary. So typically, what we do is we start off. Well, I guess I should probably introduce myself. My name is Aaron, and I represent EdmontonPy. Tonight, we've also got Ben Reeves, who represents PyData Calgary, as well as Andrew N, who represents PyYYC. So, oh, there's Ben. Hey, Ben.
Hello.
And tonight's speaker is Jay. And just before we kind of get into his talk, we'll just kind of go over the typical news. So perfect. Let me just mute. There we go. Okay, and let me just pin that right on. So here we've got YYC Data Society's website, as well as PyData Calgary's meetup link as well. PyYYC has just uh, did a refresh of their website, and so now PyYYC's got an archive that goes back to 2012. So that's really really good job on them. For EdmontonPy, we've also got just like PyYYC, we've got a YouTube channel as well. Uh, for the record, we are going to be making this recording available. We'll try to do it within the next week. And for EdmontonPy, we've got a playlist that goes back all the way to June 2019. And I just wanted to say thank you to Startup Edmonton because they were the ones who actually sponsored a lot of our meetups and purchased Remo for us. So really thanks a lot to them for doing this. And thanks to PyYYC, we've got a 1-year license giveaway for the PyCharm Professional IDE. More details, I will share them after our main presentation. And I believe, and I believe we will have 2 giveaways actually. So yeah, definitely stay tuned after the main presentation for that. And I just wanted to put out make sure we stay up to date on the restrictions and how to stay safe and get vaccinated and all that. Thought, it's a post to kind of keep this on here while we're still dealing with COVID. Next, we've got a couple local jobs, both in Edmonton and Calgary. First one is from Levin. They do a lot of embedded systems and Internet of Things, kind of in the smart home space, and they're looking for a senior software developer. They've got a Python stack. I can't remember which framework they're using, but they are looking for someone based in Edmonton. And Peasy, who create an emergency alert system. They're looking for an application developer with some mobile experience and some Python experience. They are remote okay for Canada. And third, we've also got Viewpoint Investment Partners. So I believe this is Ben's who Ben represents. And they're looking for a senior software engineer, and they are based in Calgary. Now, if you are looking for a job or looking to hire great people, we've also got a Dev Edmonton Slack and an opportunities channel there. So feel free to take a look um, at that channel. And I thought, I may as well also point out that Muckrack are also looking for, they are a fully remote company, first of all, and they are looking for a senior Django developer as well as a platform engineer. Their stack is Python based. They are a PR communications SaaS platform. I believe even the Edmonton Journal uses Muckrack. Could be wrong on that. But they are remote okay. And we have a couple people from uh, here in Edmonton that do work for Muckrack. And there's also a couple websites as well. There's a Hacker News who is hiring Scraper. I really like that website. Shows you all kinds of remote jobs. Same thing for remotepython.com and remoteok.io. I will share the slides, the link to these slides after I've gone through them. And again, feel free to take a look at the Dev Edmonton Slack opportunities channel for even more opportunities, both with Python and other stacks as well. In terms of Python events, actually, I guess starting tomorrow. So this is kind of the unofficial PyData Global pre-party, I suppose. Uh, PyData Global is running from October 28th to 30th online. And in December, one of the web frameworks in Python called Flask, they're running FlaskCon 2021 online in December. And then, super exciting, one of our former EdmontonPy organizers is now helping to organize Pi Cascades, and they've announced their 2022 online dates. So February 5th to 6th. So mark your calendars for that. And there are a lot more events on the official Python website as well. So take a look at that. In terms of news and articles, I'm very excited because last month I was talking about how Python 3.10 was in a beta. Well, now it's stable and generally available, and there are a ton of different new awesome features like better error messages. So when it says syntax error, it does a much better job of trying to tell you exactly where that syntax error is occurring. I think that's great, even for someone who's done Python for maybe, I don't know, 5+ years now. I've lost count. I like just having those nicer syntax errors. We've also got like parenthesized context managers. So if anyone has used like those with closures, now you can wrap those context managers in parentheses instead of just having a long run-on sentence with commas. If you know what those are, I think you'll enjoy what just having parentheses can do for your readability of code. And there have been several PEPs that have been merged into 3.10. For me, I think the biggest one is definitely PEP 634. That's the structural pattern matching, which in some languages you may have seen switch case. Well, in Python, we're doing it slightly different. And in my opinion, I think it's slightly better. And one of my kind of favorite frameworks in web frameworks in Python is Django. And I was excited to see that 4.0 beta 1 is available. There's now a standard library for time zones in Python 3 called zone info. And so they're, with Django 4, going to be using that by default and deprecating PyTZ. So, while PyTZ has been known by a lot of people in the community, it's time to start using our standard libs as much as we can. And they're also making sure that the use time zone default setting is now true to kind of adopt the new, best practice of our industry. And just a quick note on Django 3.2, 3.2.9 with official Python 3.10 support is expected in early November. So probably in the next week or two, you'll be able to just upgrade to that minor patch and make use of all the exciting new features in Python 3.10. I really like the Real Python podcast, and if you haven't heard enough about how much I'm gushing about 3.10, why not listen to a whole podcast exploring those new features? And I always like to kind of end these articles with a kind of more funny one. And I noticed that there was a Reddit topic where the question was, what is your most controversial Python related opinion? And the original poster said, don't overuse them, but I like lambdas. I like them too. I just don't like seeing them everywhere. So, Python 3.10. I kind of wanted to talk about, for the tip of the month, what does the match case syntax look like? So while you can, if you've used other languages with switch case, or maybe you're a newer developer and you've used like if, else if, and a lot of else if, else if, else if, and then you may have learned about switch case. Well, in Python, it's called match case. And the really nice thing about the case patterns in 3.10 is that you can actually combine several literals. So, which is something I don't see in a lot of other languages. And I think it just increases the readability and makes your code concise at the same time. My quick take is don't return not allowed for a 404 HTTP response code. I think that should be not found. But anyways, these are just little examples. And you can also use what are called class constructor-like patterns. And on top of that, you can also add guards as well. So, I may be going quickly through this tip. I will share these slides later if you want to kind of take a deep dive. But I've also supplied links to PEP 636, which is an in-depth step-by-step tutorial on the structural pattern matching that is part of Python 3.10. All right. I think everyone's sick of hearing from me. And so tonight's talk is from Jay Gupta, and his topic is customer churn machine learning analysis with data balancing techniques. Now, Jay's background, he's more of kind of like a business manager, product manager background, but he has decided to kind of self-teach and self-research and just self-apply some of these AI and ML concepts that I'm sure we're all starting to hear about. As part of this talk, I'm sure he'll illuminate what he has learned and do his best to explain some of these concepts. What I will ask is that feel free to use this general chat right here, where I will just kind of put in a hello, and feel free to post all your questions in Remo. But just for the video recording sake, and to allow for Jay to just kind of continue and provide the full picture of his concepts and of the presentation, we'll try to answer them at the end of the talk. So again, feel free to ask questions, but we'll keep it to the end. And so yeah, without further ado, I will now just pass the buck over to Jay here.
Hey, thanks, Aaron. Let me share here. Okay, can you see my screen? Let me know.
Yeah, as the organizer, I sure can. I would just kindly ask that maybe we zoom in just a little bit. That's all I would request, if at all possible.
Okay, let me know if you guys can see it.
Okay. I think if you give it just a touch of more of a zoom, but otherwise, yeah, I think
Is
that's
that
about.
better?
Yeah. All right. Thanks, Phil. Thanks, Daniel. Thanks, Ryan. Looks like we've got, 3 people's vote of confidence. That's good enough for me. I'll let you take it away, Jay.
Okay, all right. Now, I'm going to share a little bit of the business context over here before I share any of the code. Just because you guys know that I don't come from a typical developer background. This is one of the projects which we were doing for a customer in the US in the Bay Area. Now, there were a number of founders uh, who had set up basically kind of an app in one of the US cities for the US university. And what that app was doing, it was designed for university students and staff and everybody living in that kind of a university area to order any kind of food or grocery item or mats or the stationery or all that kind of day-to-day stuff within 2 kilometer zone around that university. So it was a kind of a very early starting point, but they were highly successful. And they were expanding their zone to, they later on expanded to 5 kilometer and 10 kilometer, and later on, I think a little bit more before we met those guys. So they were, I would say, quite successful, but each founder was coming from different backgrounds, so they were not the, I would say, buying in the concept of AI ML, doing analysis for these kind of things. So our first goal was that when they came to us was to have an alignment session, learn everything about them, and understand where they are coming from, and do a little bit of business analysis just to bore you guys, like the developing the personas, and doing the demographic analysis, and doing the customer journey maps and all of that, which normally is done when you basically do any kind of business analysis. So all that was done. But there was one thing which came out after all of those sessions, that there was a diverse opinion in terms of whether they are losing customers significantly or not. So they were having a very successful, I would say, business within a year, but they had no idea if they're losing people, how many people they're losing, whether is there any, there's very, very insignificant customer churn or a serious one. So the first goal was that, okay, let's establish that if this is a serious problem or not. That was goal number one. The goal number two was that in case if this is serious, where exactly is the problem? They had their business model was it was kind of a subscription model, typical like any telco company, so like Telus or Roger or anybody like that, where they had multi-tier different services model, and they had pay as go kind of a model, and then 6 months, 1 year, and 2 years kind of subscription model. So when we did this project, I really enjoyed working with those guys at the end, because it became an interesting experiment, and that's the context I'm sharing here with you. This whole experiment is divided into 3 notebooks. The first notebook is all about, first of all, establishing that what kind of customer churn is there. So that was goal number one. Number two is, where is that located? Is it under a specific type of contract or all across? So that's goal number two. And goal number three is, can we identify the using the machine learning techniques if some of their problems can be addressed ahead of time proactively, so that they can decide before somebody decides to leave that they have much intense customer touch points through some kind of a marketing campaign, so that they can keep those customers and don't lose those customers, because customer acquisition costs can be very, very high. So those were the goals. But as we were trying to start that experiment, we realized that there was huge disagreement on, because there was some knowledge within that founders group that, hey, we have to do data, balancing techniques, or we don't have to do, or I mean, all kind of issues were noticed. So then we told them that we will run all possible scenarios. So, and then we will compare everything. And at the end, you guys decide, we will make our recommendation, and then you guys decide how do you want to proceed for the last stage, which was the app development for them. Now, the app development has not been done by me, so that's something you guys would be missing. But other than that, everything else is I'm going to share in these 3 different Jupyter notebooks. So the first notebook is where what I'm doing is I'm basically, loading analyzing the data, loading the data, everything, all of that. And then it's a full-fledged analysis going up to the modeling stage and seeing that which machine learning technique is going to work better for this scenario. So there was no, I mean, their data is highly confidential. So, I mean, I don't have access to. So what I did, basically something similar I found from open source, which is from IBM. Of course, this is for telco, but there are many similarities. So that I hope gives you enough information and the background that when we're talking about churn, now in this case, we're talking about telco churn rather than that particular customer churn, but there are almost, I would say, very identical scenarios here. So the way I like to do these kind of things is I normally, first of all, import all the core packages first. Now I had downloaded the data set, and so that data set was available on my machine. And then I loaded that data set over here. And these are the columns. So customer ID, gender, senior citizen, partner, dependents. So all the demographic information and the services, whether they have multiple lines or the internet service or streaming, what kind of contract they have, what kind of payment method they're using, what's the typical monthly charges for each customer, because you see over here the customer ID is there, and then the total charges, and then the churn at the end. Which is our target feature in this case. Now, just so you know, when I'm looking at this, I would not see any question or anything. So if you have anybody has anything, Aaron or Ben, you can stop me, and then I can stop if there is a need for me to stop anywhere. Okay. So the goal number one, as I said earlier, was that, okay, let's focus on churn and see, is there any churn or not? And guess what? As soon as I did this simple code and I showed them these two analysis, and then they said, oh, they were thinking that their churn could be somewhere around 1 to 5%. Because they were not analyzing the data much. They were running the business successfully, they were happy, but they were hardly doing any kind of analysis. It was all kind of go, go, go most of the time. So and they were approximately around 8,000, so it's pretty close to their numbers also combined. If you look at no and yes, yes is the, under churn scenario. So if you look at here in terms of percentage, there is 26%. And in their case, it was close to 28%. So that much churn was there. So we achieved the goal number one in a very, very simple step, just by looking at the data, and they said, okay, I am willing to listen now more. Give me more. So that's how we overcome some of that initial resistance. When as soon as we showed them just this simple analysis, they said, okay, let's carry on. So looking at basically the data, we found that because this is for the telco, the tenure is basically on an average is 32 months. This is in months, just so you know. And senior citizen is 0 and 1, so that's why you see some of this odd, because it's a kind of a numeric number here, but it's basically a category. The monthly charges approximately 64, and total charges is basically cumulative charges, which are average cumulative charges. And this gives you the quick kind of a take on minimum as well as the maximum charges. Then we checked it out, the missing values after that, and then the real fun started for them, because as soon as we started sharing, saying, okay, here is a churn scenario. So this is on the churn and the total charges. Now, do you see here that when people have, like people are leaving, they're leaving, very, which they are paying. In fact, total charges are way less compared to the one who have the contract. And the reason why the total charges is higher over here, because they're under the contract, so they are willing to continue for longer duration. So over the time, you're making much more money by having people on the contract rather than keeping the pay as you go, because their scenario was more people under the pay as you go rather than under the contract, because they were somehow more inclined selling all the time rather than converting people from pay as you go to the contract side. So that was our goal number two. How do we convince them that it's much better to convert people from pay as you go to the contract side, because that in over the time you'll make more money from that one customer. So carry on. If on that, the monthly charges, if you look at here in terms of analysis, the overall charges, monthly charges, are a little bit higher compared to the contractual one, because when you're under the contract, it's obvious that there would be some kind of discount being offered. And that's the reason why more and more people were leaving under pay as you go. And so we showed them that and say, yeah, no, I think it makes sense. Then we started analyzing for the different contract scenarios, and started showing them those pictures. So here is a picture for, this is pay as you go, which is, in case of this, it's month to month. This is 1 year contract. This is 2 year contract. And in this case, as if you look at here, all this color is for churn, and this is for no churn. The blue is for no churn. So, in case of month to month, we immediately looked at and we decided that, yeah, you know what, it may not be giving you the good picture here because it's total charges. But at the end, if you look at over here, the total charges for the 1 year, so people are leaving after 1 year. Have you noticed that? Are you doing anything about it? People are leaving after 2 years. Have you taken any kind of steps to bring them back or keep them by extending their contracts? We started having that kind of discussion just by looking at that picture. Now we said, okay, you know what, let's go further and look at the monthly charges. Now, monthly charges, because people under contract started having more bundling. So because of that, it is obvious that when there is a bundling of different services, as a company, you're going to make more money. And this was the myth for them, that they were looking all the time on this sector, which was month to month or pay as you go scenario, because they were charging higher. They were thinking that's much more beneficial for them. But if you look at just this simple picture alone, you'll notice that a company can make more money by bundling services and offering more to the existing customer. And that's what it's communicating. Then after doing all of that, so basically they were like, just after doing this simple steps, they were converted, and then they were willing to listen, and they were willing to look at much more in depth. So I'm taking you also along the, along with me, the journey which we have taken with those customers. So now, in order to do the kind of a meaningful correlation analysis, you remember most of the other columns were categorical, so and not numerical. So in order to have a meaningful correlation, what we're doing over here is we are converting everything into numerical first, and then after that we are running the churn kind of correlation over here and plotting this in this format. Now, there's a direct positive correlation, from churn perspective. So, it's obvious that pay as you go or month to month contract will have the highest kind of correlation with people leaving. Now, some of these features are where people have less number of features as part of their services being utilized, and those who have just one service is likely to leave early than those other people who have multiple number of services. So that was the message which communicated through this picture. And this is a negative correlation, and which says that if you're under the contract, there's a negative correlation that you are not likely to leave. That's what this picture is communicating. So then, based on all of that, they said, okay, I hear you, and you guys can continue and do more, and can we now look at different contracts? So that's what we started doing as part of the customer segmentation. We said, okay, let's look at the different tenure. So this is just giving the overall picture for different tenure, and then how many people are there under each. So it's a histogram communicating just the number of people who have signed up for different kind of contracts. And then we did the churn analysis based on that. So this is no churn, top is no churn, and bottom is the churn. So you'll see over here that people who had kind of, the first one is who are basically pay as you go, a month to month contract. You could see this kind of a spike over here, which communicates clearly that the best thing we can do as a company is to convert people from this category to different contracts. Even if it's a 6 months contract in their case, it's much better to convert the pay-as-you guy towards a contract, because then they can groom that customer over the time and offer them more services, better services, and much more kind of meaningful engagement over the time. And in the process, as a company, they make more money. So this is just a scatter diagram showing some of those monthly charges and the total charges for churn scenario, which is this color, which is, I don't think it's a good presentation over here. But now, based on that cohorts, what I'm doing over here is I'm grouping it everything for different tenures, and then I'm running the churn scenario for that. And I'm going to show you the picture over here, which shows that for different tenure, as you see, one month, 2 months, 3 months, up to 72 months. And this is the churn rate. So 1 month, which is basically as good as kind of pay as you go, there's a high, very high churn rate. Over the time, it's coming down as basically we are converting people, then they're less likely to leave. I think this gave them then kind of the whole commitment to keep moving with the contract. Until that time, they were not ready to move further. But after this, they decided that they will invest more, and then they'll ask us to keep moving, keep doing everything what needs to be done. So then later on, we just basically converting this into different categories here, and then doing a scatter plot, showing them that monthly charges, that myth that you can charge more from pay as you go is really not right, because over the time you make more money, more monthly, total charge. If you look at here, total charges is much better if somebody is there for a longer contract. So then they said, oh, I get it. There's no need to sell it further. You guys have convinced us that their existing model is really not a workable scenario. And the customer acquisition cost is so high that they need to start paying attention. So then they said, okay, fair enough. Let's now start looking at the machine learning, and let's start looking at that. How do we train a model so that we can start predicting every month that who's likely to leave, and that would make sure that if somebody is likely to leave, that then we can have a customized touch point, which is basically a kind of a marketing campaign, which first of all educates that customer that, hey, there are more services which you can get the benefit of, and also we are offering a discount because of you have been with us for such whatever the duration is. So keeping that in mind, then now over here, I'm basically training the data. Creating X and Y. So splitting everything into that. And you remember those categories. I'm basically converting everything to numerical over here, and then splitting training and testing data set, and then using the standard scaler to transform everything. And then one by one, because if you remember, there was a disagreement within that group, that number one, whether the data balancing is required. One was saying no, we have to, and other was saying no, we don't have to. So now we are going to run the first scenario where we are going to use a variety of different machine learning algorithms, and we're going to compare everything, and we are going to show it to them, so that there is nothing kind of like they don't feel that they have not seen the results from different algorithms. So that's what I'm doing over here in this kind of section, that I'm using logistic regression here, decision tree classifier, ADA boost classifier, gradient boost classifier, random forest, that's a support vector, and then KNN. And then in order to evaluate the results, what I've done here is I've created a function here, which is model results, and I'm plotting the confusion matrix, and I'm also printing the classification report over here. So I've created a function rather than keep doing this again and again, and just using this, so automating everything as much as I can. Deliberately, there is no pipeline being used here, because those, remember, everything we moved inch by inch along with them. We never moved fast because there were lots of resistance over the this whole process. So then logistic regression, we just basically printing everything over here. Now, rather than going through one by one, what I'm going to do is I'm going to show you at the end the comparison for these different models, and that would show you that the results on this, and also what was the outcome of this. So decision tree classifier, random forest modeling, and the ADA boost, the gradient boosting classifier, KNN, and that's the SVC. And here is what I'm doing. I'm bringing all those results over here, and then I'm creating a data frame based on that, and then putting this tabular form and looking at the results at one place. So if you look at over here, and the cutoff point for along with them, which was decided by engaging them collectively, that the cutoff point is 80%. Anything less than 80%, they are not going to look at. So logistics regression is something which is making through. Descent tree is not, so that's out. Random forest is in. AdaBoost is in, Gradient Boost is in, Cannon model is out, and support vector classifier is in. So that's what basically we filter down by doing this kind of experiment. And then after that, remember, I have not done any kind of data balancing technique so far over here in the first Jupyter notebook. In the second Jupyter notebook, but before I go to the second one, I want to make sure I go back to the presentation and see if there's any question or anything. I know I'm going to look at everything at the end, but let me know if you guys can see so far everything what I have been saying, any issues, because I just want to make sure I'm not
Yeah,
speaking blind here.
from my side, Jay, everything's looking pretty good. So again, we'll if there are questions, we'll just keep them to the end. But feel free to carry on.
Okay, thank you. Okay, so here is the second Jupyter notebook. Now on the second one, what I'm doing over here is their desire of making sure that we use all kind of data balancing technique. So we are using oversampling, undersampling, and SMOTE. And then after doing all of that, rather than using every single algorithm once again, only using those algorithms which were filtered out during the first Jupyter notebook. So this is same. So I'm going to skip this initial part, and I'll stop at the data balancing over here. So on the data balancing side, I'm importing the required packages, which is the resample and the SMOTE over here. And then you remember we had the model, like everything split earlier into training data set, and so X and Y. So that's what I'm concatenating here and creating a data frame, which is DF train, and then putting this together in order to start the data balancing techniques. So we are not touching the testing data set at all. That's totally kept separate, never being running through the data balancing scenario. So the first one is the upsampling or the oversampling. And again, everything we are looking from churn perspective. So that's what I'm doing over here, no churn and yes churn. And if you remember, the no churn was pretty like 1800 or something kind of number compared to yes churn. So through this resampling, we are taking the, we are upsampling the no to a number which is equal to the yes scenario. That's what we are doing over here. And then after that, because this, remember, this is now combined X and Y, so we would have to break it down. So that's what I'm breaking it, splitting again into X and Y. And then we have to use the standard scaler again to make sure that everything is good for machine learning processing later on. So that's what I'm doing. So the next step here is the downsampling. Now, in this case, because we are going to reduce the yes scenario to a lower number, and so that's what this scenario is. That no scenario is 1722. So yes is also brought down to 1722 using the same resample technique over here. The third one is, and then these two steps are same, X and Y, and then, using the standard scaler. Then SMOTE, so created the model for SMOTE, and then created X and Y training data set for SMOTE. And then using that, basically created this scenario. So this is synthetic data for, in this scenario for no. And as you can see, everything is balanced, totally balanced. So in all three scenarios, everything is totally balanced. So that's kind of the confirmation. We showed it to them and they will say, yeah, they can see that. Now we're starting with the machine learning over here. Now keep in mind, in the first Jupyter notebook, we did not do any kind of hyperparameter. So there is no hyperparameter training in the first Jupyter notebook. Even in this case, what we are changing is there's only one parameter which is being changed, and that is that we are using these different data balancing technique, but we are still keeping everything in terms of hyperparameters, same default hyperparameters. There's no change on that. Now, all those same steps which we did earlier are being done over here. Same evaluation, that method is there. So that's the logistic regression. And then now what we're doing over here is that we are running logistic regression for upsampled. Then at the same time, we are also running it for downsampled. And then at the same time, we are running it for a SMOTE. And then we are saying, okay, which one is better? So we are comparing, each one on the ongoing basis. So as you can see here, for logistic regression, SMOTE is the best scenario. So we keep comparing for each scenario so that at least we can see the pattern later on when we look at the results together. The next one is the random forest classifier. And if you look at over here, upsampling is the best scenario for random forest. Then for AdaBoost, SMOTE is the best scenario for AdaBoost. This is for the gradient boosting. And I think SMOTE is again, SMOTE is again the winner in this scenario. This is for support vector machine. And I think SMOTE is again the winner. Yes, SMOTE is again the winner in this case. So overall, if we look at everything together at one place, then putting it together over here, we can see that SMOTE is the winner. And then we further narrowed down based on this information that we're going to focus on logistics and gradient and support vector classifier for SMOTE. But what about if we compare SMOTE, that which is a data balancing technique, versus no data balancing technique? So that's the next part of this. So you remember all that results we had earlier in the last notebook. Now we are comparing here original data with the SMOTE data. And then we are comparing the results over here for those different algorithm. And based on this, if you see here, original data logistics regression is better. Random forest original data is better. AdaBoost original data is better. You see the pattern over here. Everything with original data is way better. So basically, we convinced them that there is no point of using these kind of different data balancing techniques over here, because your data is not that much imbalanced like a fraud scenarios. So it's okay to keep moving based on what you have. Because a complex model means more computing, and over the time it doesn't give you better results. So let's continue with the original data set, and then focus on now on the hyperparameter tuning. And basically that's the third Jupyter notebook, where what I'm doing is keeping everything same. The only one change which is over here is now we are focusing on the hyperparameters tuning. And also number of algorithms have been reduced. As you can see, it's only logistics, AdaBoost, and gradient boosting and support vector. So for the logistics, we are basically hyper tuning only two parameters. First one is the the regularization, which is basically L1, L2, and elastic net. We are just looking at in terms of penalty, and the learning rate. We are just running different values over here, and then checking, creating that parameter grid, and then checking based on that, what's the best parameter. So these are the best parameters. And based on these best parameters, then we are getting the value again. That's what we're doing. Same thing in case of AdaBoost. The only difference is number of, like the hyperparameters are different. It's number of estimators in the first case and the learning rate. And based on that, then we are finding which one is the best. And then we are getting the results over here. For gradient boosting, again, we are checking for number of estimators, learning rate, and maximum depth also. For the support vector, we are checking for C value and the gamma value. and then we are putting everything together over here. And then based on this, we are looking at the values. And then based on this, if you see, the results are pretty kind of close, I would say. Um, Now, collectively, it was more in terms of deciding that, okay, where is the minimal false positive or false negatives? That's where we should focus. So that's what we were kind of talking and discussing all the time. But at the end, we left the decision to them, saying, you decide which model you want to pick, because that's something which we can use as a pickled file in order to create some kind of app where every month you're going to load a file for the new data, and that is going to tell you the likelihood of somebody going into the churn mode. And then you, based on that information, you start your campaign, because that information would give you information who are likely candidates for that, and then you start the campaign. So based on this, what I can share with you is that um, they reduced, and this was kind of a happy moment for us, over running this simple analysis, simple kind of the whole process. They reduced from 26% to less than 15% within a span of 3 months. And that's the power of doing experiments. That's the power of working together and sharing everything, being transparent, and giving them the full transparency, and showing them everything. That's what we realized, and we as a team were extremely, of course, happy. They became our one of the best promoters later on, because of all the success. I don't have the latest information, because um, after that 3 months, they basically shared the number is much less. I don't know exact number, how much, what is the less mean for them. Is it less than 10% or around 10%? I have no idea about that. So that's what basically gives you in basically nutshell, at the high level, everything what basically would help when you do the experiments. Now I'm open for questions, Aaron and Ben.
Perfect. Okay. I just kindly ask that you just hit the stop sharing button,
Okay.
and then that way it'll just kind of do the webcam thing. We'll ask you to pop up the screen share again if needed. But I guess since there aren't any questions yet, but in the audience, feel free to just fire on. Um, we've got about half an hour left in the meetup. But my question is a simple one: is this GitHub? I noticed that your notebook was on GitHub, so is that repo public by any chance?
I am going to share that.
Right on. Okay. And yeah, I noticed there were a couple claps uh, you know, flowing through here. So
So
yeah.
this is one thing which I love to do, is anytime I do a kind of a very typical project or unusual project or experimental project, I love to find the open data source,
Hmm.
which could represent something which has been done.
Right.
And remember, when you're doing as part of the team, you have so many people. But then in this case, then I do everything all by myself,
Hmm.
and I try to put it, for even for my future reference, so that it can help myself.
Right. Yeah, I
Yeah,
noticed that you were saying in the presentation that this was kind of using open data, but
yeah,
actually the case study is real. Like you were hired, you know, or responsible for a very similar problem, and within 3 months, by applying some of those concepts, they could see a tangible benefit in just 3 months.
absolutely, absolutely. Yeah, you said it so nicely over here.
Perfect.
Yeah,
Yeah, if there aren't any questions, well, if there are questions, again, feel free. Um, even if it's just kind of a softball or what might feel like a beginner's question, honestly, this is that opportunity for people to just ask. Um, if there aren't any questions, what I will do is I will basically share kind of the conclusion slides, I call them, um, right now. Ooh, actually, looks like we have a question. Perfect.
Yeah, and I think that's a very important one.
Yes. So just so that for the video's sake, I'll articulate Stern's question here. What scenarios SMOTE would perform best compared like best versus normal oversampling or undersampling?
Yeah. So I have worked a lot in data fraud scenarios. Actually, that's one of my expertise also. I have noticed based on that for many of those financial fraud scenarios, either with the credit cards or with the even the normal banking or any kind of app banking, running these different scenarios for data balancing is extremely important and required, I would say. And in many of those scenarios, I've seen SMOTE really doing its job. So thanks, Stern. I think that was a very good question. So anywhere
Perfect.
when you have data highly imbalanced, like 99% everything is okay, 1% is kind of sitting in that kind of category which you have to define. Those are difficult scenarios, and that's where SMOTE can really do much better job.
Right on. So on the topic of SMOTE, in the Q&A tab, I noticed there's a question. Did you play with the SMOTE's like hyperparameters?
Uh, Again, it's extremely good question. I did not, because remember I was dealing with so many challenges all the time as a team from our founders,
Hmm.
because they were not really someone who were willing to go an extra mile, and they were more interested into let's do what we can with the minimal money and minimize the effort. Now, when we made the final recommendation after doing the app, we gave them a couple of recommendations, and that's one of the recommendation is that let's uh, once you have more data, let's take this journey again. And then at that time, because with now lower churn rate, some of this scenario which we have now may not be applicable. So there could be model drift because there's the data drift over here now. And so some of those scenarios could be where you need to keep working over the time. So don't rely on this same pickle file for forever. That was a message to them. And also keep looking at different algorithm and keep doing the hyperparameter tuning and see which one works better.
Yeah, I think that's I come from a web development background, and so the way I interpret that response is um, the models that you've created now. First of all, you didn't tinker too much with the hyperparameters, and yet for me, it's very uh, useful to know that even if you haven't touched those hyperparameters yet, there is a tangible business benefit to just using the defaults, and we can already see in 3 months lower churn rate. But then on the flip side, you can't just stick with that original model. That like you said, model drift and data drift mean that you have to re-examine how you know how you're actually examining and analyzing this data, because now you have a different problem solving for a 26% churn rate and dropping that, versus if you can get to the point where it's like a 10% churn rate and dropping it down to 1%, you may need to do a bit more involved work with your data analysis and machine learning.
Absolutely. Yeah. Well
Right
said.
on. Okay. I didn't notice any other questions. So, again, feel free. And even once I drop this out of the presentation mode, we go back into the whole roundtable thing. So if you find a J, it's kind of like a Where's Waldo sort of a thing. But you can always just drop into the table that Jay's in if you do have any questions. But again, thank you so much, Jay, for doing this presentation and answering these questions. For me, my takeaway is things don't have to be perfect to be able to provide a business with tangible, like beneficial insights. So that's something I've taken away. Um, and again, thank you so much, Jay. From here, I will go back to the conclusion slides. And our next meetup will be on November 24th. And just like every month, we are looking for presenters. Um, and beginner talks are also encouraged. So I believe last month we also had more of a beginner oriented talk as well in the data science field. Again, I'm a web developer, so if there are any people who are doing, using Python in the back end, I'd really love to see those talks as well. There's also been, I remember there was one where somebody was creating a storytelling framework using Python. So it doesn't have to be web, doesn't have to be data science. I love Python because it's in so many different domains, and in many domains I don't even know about until someone walks up and well, virtually, I suppose, walks up and says, "Hey, I'd like to do this talk on something that I learned or discovered in Python." Again, you can message either myself at Aaron Young, Abram, and Andrew Krause's handle. That's probably the easiest. I know that there's also Ben and Andrew from the two Calgary meetups. But just to kind of couldn't fit everyone's name on the slides. But yeah, it's easiest if you could just get in touch with any of us. We'd really appreciate that. And I'm sure for some of you in the crowd, you're in here because it's time to do the giveaway for the PyCharm IDE. So the only thing I ask is that if you are the winner, to basically provide in private. Oh, that was shown on that screen, wasn't it? Yeah, basically provide an email address if I do draw your name. Um, let so to add people into this list, I think all I would need is that you just type in the general chat something, and that way you'll basically put your name in for the draw. And let me just flip this over. There it is. Pete knows exactly what I'm talking about. Okay, so let me just make sure. I've only got two monitors. Why is this so difficult for me? Okay. Alrighty dighty. So what I've done is this is basically an over-engineered. Let me go into the README. Everybody loves READMEs. And then let's zoom into said README. So Python's pretty awesome. I basically over-engineered what's already built into Python. It's there's a basically random module in Python, and all I have done is essentially use random.sample. And the super cool thing about random sample, and something that has like been very applicable right now, is that we have two license giveaways. And the nice thing about Zample is that it will actually it even has it right there, raffle winners. It will do it appropriately and basically not cause, if one person won one prize, they're not going to make that person win the second prize as well. So I really like that this exists. um, there really was no reason why I decided to over engineer it other than I wanted to scratch the Python itch. I haven't, even though I'm the Python organizer, I haven't really programmed a lot of Python lately. So, okay, let me just start adding some names in here. And yeah, sorry to the organizers and speakers. I simply cannot let us win. Let me just make sure that everything is all installed here. And I will just start copy pasting names. And I am sure there must be some kind of Remo API, or like, I know if people are watching Twitch TV and stuff, they got like those, exclamation mark, blah, blah, blah commands. If anyone does know a way to make this go by a little smoother, that would be much appreciated from my end. Otherwise, okay, and then last but definitely not least, there we go. Okay, And because I already forgot how to even run my own program, all right, so I've done the poetry install. Yes. Uh, oh yes, shameless plug for our EdmontonPy YouTube channel. We did have a talk on what poetry is. It's if you know about dependency management in Python, you may have heard of pip and requirements.txt. But nowadays, something I really like about Replit is that they're using poetry now with the pyproject.tomo format. So it's a little more structured than having requirements.txt. But I don't think y'all were here to kind of have me do a talk on this. There is a YouTube video on that. You were here to watch me actually run this bloody program. So um, again, this is literally it. It's just random.sample. Nothing really much. Well, I guess I'm reading from a text file. Okay. So because we have two licenses to give away, okay, copy pasta does not work. That's okay. Wayfinder, and let's just double check. Make sure nobody did pull the sneaky on me and type their name twice. No, everyone is very honest. I appreciate that from the audience, and I will essentially run this. Okay, and so the winners are Pete and Hamid. So congratulations, yay! Basically, send me your email in a private chat, and I'll coordinate with the PyYYC organizers to get you a link or whatever it is, license key. I'm actually not sure, but they have done this many times in the Python meetup in Calgary, so I trust them. There are two licenses for sure. With your email, they'll be able to get in touch with you, Pete and Hamid. So congratulations once again. And I'll just go back here again just to say that it has been a pleasure to see all of you. And thank you once again, Jay, for providing your talk. Again, I got key learnings from that being a web dev, and so I think you've done a really good job there. And thank you for sharing the Jupyter notebook. And if you liked what you saw, we're back at it again on November 24th. We are also looking for presenters. Um, and with that, I will wrap up the presentation here. And again, the room will be open until about 8:30. Then it'll kind of kick everyone out. Um, oh, thank you so much, Andrew. Yeah, he's one of the helpers of the Python, PyYYC. There it is, blanking out. On that note, yeah, you can feel free and stick around, mingle until about 8:30. But once again, thanks everyone for attending October's Python across Alberta meetup, I suppose.